Hi guys, welcome back to Dr. Abha Chemistry Pathshala. Now we are towards the end of the chemical properties, that is the chemical properties due to presence or absence of alpha hydrogens. So we did cover the chemical properties due to the presence of alpha hydrogen in the previous lecture where I had taken up aldol condensation, and this particular lecture is about the reactions where aldehydes, only aldehydes, mind it, not ketones, very commonly admitted error. So in which aldehydes, they undergo a special kind of reaction which is a disproportionation reaction, a kind of condensation to give respective products. So without wasting time, let us quickly jump onto the screen for a better explanation.
Started with the video, and the topics for the video are Cannizzaro reaction. What is a disproportionation reaction? There's a very close relation between Cannizzaro and disproportionation reaction. So we'll be doing disproportionation reaction, and then we move on to how Cannizzaro is taken as a disproportionation reaction. Next is the difference between Cannizzaro and cross Cannizzaro reaction, and the last will be doing the mechanism of Cannizzaro reaction. So what is Cannizzaro reaction? Cannizzaro reaction is a kind of a disproportionation reaction. It's only for aldehydes. It's only for aldehydes which do not have alpha hydrogen. The reaction takes place in presence of strong alkali or base. It produces respective alcohols and acid salt. So whichever aldehyde we start with, the same number of carbon atoms, we will have the acid salt and the alcohols. We start with methanol, we will have methanol and a salt of methanoic acid. What is a disproportionation reaction? In a disproportionation reaction, the same species undergoes oxidation and reduction simultaneously. If we look at hydrogen peroxide, here the oxidation state of hydrogen is +1 and of oxygen it is -1. Here again in water it is +1, -2, and in oxygen it is 0. So if you look from here to here, there is a case of reduction from -1 to -2. The oxidation state of oxygen has gone down. So this is a clear-cut case of reduction. And if you look at from oxygen to OT, O2 to O2, here there is an increase in oxidation number, so this is a clear-cut case of oxidation. So same species undergoing oxidation and reduction, so this is a disproportionation reaction. Let's find out how Cannizzaro is a disproportionation reaction. In Cannizzaro reaction, the aldehyde in presence of alkali, usually we take 50% alkali or concentrated alkali, it converts into the salt of acid and an alcohol. If you see, this is a 1 carbon aldehyde, so we have 1 carbon acid and we have 1 carbon alcohol. So this is okay. So this is Cannizzaro reaction, but how it is disproportionation, let us find it out. So now if you look at the oxidation state of carbon is coming out to be 0, and here the oxidation state is coming out to be +2. Here the oxidation state is coming out to be -2. So from here to here, it's a clear-cut case of oxidation. Formaldehyde to methanol, it is a clear-cut case of reduction. Hence, it is a disproportionation reaction. Difference between Cannizzaro and cross Cannizzaro reaction. So if you remember the last video where I had taken up aldol and cross aldol, this is very similar. Cannizzaro will take place for two same molecules of aldehyde without alpha hydrogen. Methanol, benzaldehyde, tert, butyl carbaldehyde. So I take an example. I take methanol, I take alkali, and what we get is, we've just done before, sodium formate and methanol. This is nothing but self aldol. Here this only is getting oxidized and reduced. We take different aldehydes, both the aldehydes are different. We take alkali, and the one which is less bulkier, that is the formaldehyde, will give the acid salt, and the other one will give the alcohol. Please mind it, the alcohol will not be phenol as very commonly admitted error by most of the students, but just if you look at the number of carbon atom, you will come to know that the number of carbon atom has to be same, so it is benzyl alcohol. So we get formate ions actually we'll be getting the salt depending upon which base we have taken here, and this is going to be benzyl alcohol. Okay, so let us do the Cannizzaro mechanism. So we take benzaldehyde, and the first step is the nucleophilic attack of OH minus on the carbonyl carbon, and what we get is, so we get alkoxide form. This is usually, if you remember the nucleophilic reactions which is undergone by aldehyde and ketone, this is the nucleophilic attack, the first step, right? Okay, now here it is the fast step, and the next step is the slow step. Here what happens is, this is the same alkoxide, it reacts on the second molecule of benzaldehyde and shows the proton transfer. Here hydride is, and it shows the hydride transfer to give us. So this is what we get as the acid, and this is what we get as the alkoxide, right, of alcohol, right? In the third step, this will get shifted to this oxygen, and this H plus, it gets shifted to this O. So what we have is, we have this doubly bonded O, and we have this as carboxylate. We have this as benzene carboxylate. So basically what has happened is, the proton from here has got transferred, this proton has got transferred to this oxygen to give an alcohol, and the second product what we get is, we get pH, and then we get all hydrogens, and here we get OH, and this is benzyl alcohol. So this was all about the mechanism of Cannizzaro reaction. So we meet next with an interesting topic of aldehyde, ketones and acid. Till then, take care of yourselves. God bless.